In this section of our course, we're going to discuss C++ standard library containers and also other components of C++ standard library. So this is our presentation. So STL stands for Standard Template Library. It was basically a conventional name early on in 1994 for the initial C++ standard library. And whenever possible, I try to use the library to avoid reinventing the wheel and therefore avoiding making mistakes and generating unnecessary bugs, because the library code is very well tested, very proven, very efficient, and it's also extremely portable. So your code will be portable to other platforms without a problem. And standard library brings you a lot of functionality, so you can rely on specific components of it, and it will make you feel like you're doing a great progress when working on your projects. So the standard library can be viewed as all C standard library, support for strings, support for stream input-output, including different devices and files. Also numerical computation such as complex numbers, and support for vector math. And in terms of the data structures, we can rely on a variety of different containers in the library and algorithms which can operate on these containers and perform different tasks. So STL components support generic programming because they're all based on C++ templates that can be parameterized by the types that you like. And containers are objects, and they are vectors, lists, maps, and we're going to experiment with different kinds of them. Iterators are objects behaving like pointers that define ranges inside containers. So the iterator basically remembers the container and position of the element to which it's pointing to. So the pointer, which is very primitive type of iterator, only remembers the address of an object and the type of an object that it's pointing to. The iterators knows a little bit more about the object that it's pointing to, like container type, what kind of elements the container contains, and it knows how to navigate forward and backward and be repositioned within this container so that the container can be accessed through the iterator. And also, of course, using the iterator, if this iterator provides mutable access to the container, we can update elements inside the container using the iterator, and also read the elements. So the algorithms are simply functions, and the examples are sort, count, copy, and so forth. So the algorithms require iterators to specify what is the range on which this algorithm should be applied. For instance, you can sort the entire vector, or you can sort only portion of the vector. So this gives you a significant flexibility, and basically you use containers, iterators, and algorithms in combination all the time. To obtain an iterator, you typically call a container function which returns back an iterator. So it's not that difficult to start working with this. You create container, you populate container with some values, then you obtain an iterator and or a couple of iterators to specify the range within the container, and then you call the algorithm to do something with the container. So this is pretty nice set of facilities. So iterators, of course, are objects, and algorithms are functions. So we have seen examples of our very basic type of container, vector, which basically is trying to emulate the behavior of a primitive array. However, it's a dynamic array that allocates and deallocates memory for you dynamically in a very safe and convenient manner, so you can just populate it with any number of elements you want and start using them. So of course, because its model is C++ primitive array, of course you get random access, which means that you can use square brackets to access individual elements in the order that you like. And you can quickly append and add new elements and truncate them. If you recall, we had a demo of vector stack operations, push back and pop back, to add and remove elements at the end. And here on this slide, it says that it may be slow for inserting data in the middle of the vector, but it's not really true anymore with a great advancement of cache memory, because just a lot of benchmarking shows that vector is by far the superior in terms of almost any kind of operations, because if it's cached in memory, CPU cache is optimized to an amazing extent, and it will be actually not bad at all to insert or erase elements in the middle of the container. So of course, dynamic means that its resizing is managed for you. And of course, it also manages the memory. So it's like a memory manager object. And this memory management, which can be a pretty challenging task. So we've seen similar examples already. So basically, the containers such as vector require you to know which part of the library to include, the header file. And then you use the angle brackets, so these are called angle brackets, to specify the type by which the vector is parameterized. In other words, if you want floating point numbers, you say double. If you want integers, you say integers. If you want strings or some other type of object, you just specify that type inside the angle brackets. Also, constructors. There are constructors, different types of constructors that we also already discussed in our samples. And one example I can show you that we haven't seen in our presentation, that for instance, if I include vector, in my code, so now I can say, let's create a vector. Of course, everything from the library is sitting in a standard library namespace. So let's say that we want a vector of integers, and we can give it a name. I'll just use something very simple like vi, vector of integers. And using the initializer list, you can populate it with values just like this, right? So if you already know what the initial values should be, you really don't need to code or write code like this, vi push back, like attach, or append rather, push back these values like 10 and 20 and so forth. So you really don't need this if you already know what this is. If I already had some variables, integer variables, such as value 1 equals 10, okay, so it could be already loaded from a file or specified by the user, so we could use like 10, 20, and 30. So here we could do, and this would be our examples of our variables. Now here we could just use variables as well, v1, v2, okay, and v3. So this is all fine. You can construct vectors like this. So this is a universal initialization type, like initialization list, which gives vector initial value. So all you have to do is just remember how to use the syntax. You see that this is all working fine. Alright, so the vector is actually using internal allocator, memory allocator to manage memory. It's also part of the library, and you can write your own, but this is more advanced type of programming, because normally you should be pretty satisfied with just, you know, specifying only the type of the data elements to contain in the vector. Of course, the default constructor is constructing an empty container if we use default constructor without any kind of initialization. This initialization syntax is also can be done like this. Okay, so if you prefer this syntax, it does exactly the same thing. I noticed that lately people prefer a shorter version of it mostly, and I think this is the way our online tutorials present this material. We have seen also examples of accessing vector elements. So if I wanted to print the individual elements of my vector, I can write code like this. I can just use an index. Typically you want an unsigned integer type, such as size t. I use this very routinely when I need an unsigned integer, and say this is my index, and this index should be less than vector of integer size. Okay, so this is my container size, and I routinely increment the index right here, and now I can print elements like this and display them using square bracket notation. And of course an index provides access to individual elements, and we can add space over here, and at the end of this loop we can probably print a new line just to maintain a good formatting on our output. And if we build it like this, I keep forgetting to initialize index. Okay, so we start with 0. Of course, indexing here is 0 based. Okay, so if we run this, of course it's trivial, it just prints the numbers on our screen. And if you only have a loop which wants to have access to every single element of this vector, it's possible to write a simpler looking loop which is designed to visit for each elements inside the container. And we can say that for each integer, for instance value, and here is the colon, not semicolon but a colon. Okay, so in this container vi, what I'd like to do is just print the individual values. So this time I will be printing the value, right? So let's compile this code and run just to be sure that everything works fine, and I'll show you the difference between the two loops. Okay, so both of these loops access our integer container vi populated with these values. And obviously the initial loop uses the index variable and square brackets or subscript access to individual elements, whereas the second vector, second example, does the same thing a little bit different. It's first of all, it's a read-only access, because what it does, as our container here is populated by these values. Okay, so this is somewhere in memory we have these values, 10, 20, and 30. So this is our vector. And in this second loop, the value is an integer. So in this loop, the way I wrote this, with the colon and the name of the container, each individual, so internally this loop accesses every element sequentially from the beginning to the ending of this vector and copies the value in each iteration. So for each element present in the vector, there will be new iteration that we're going to be entering this loop. And the copy, every time a copy of value 1 is copied over to the value, and we can print it. Then next iteration copies the next element to the value, and we print it. And then to the next one, and so forth. Okay, so this is called for each loop, sort of like its limitation is that it cannot limit access to a certain range of elements. It will access all of them, and that's the idea. Every time you need to iterate through individual elements, and this should be your first choice for the type of the loop that you want to create with the vectors.